Hello, my name's Labib. I was just stargazing at the star Polaris, which is now covered up, unfortunately. What I'm going to explain later is how the universe and the Omniverse was created. It's the most challenging question mankind has faced. Even now, scientists don't have the true real answer. First, I will explain the few accepted theories. After that, I'll explain what I think created the universe and the Omniverse. Just to let you know, the Omniverse was a new theory, so scientists have only hypotheses to explain how the Omniverse was created. Okay, here we're back in my room. Now I'm going to explain how this universe and this Omniverse came to life. Well, how it began. There's thousands of theories and hypotheses. Most of them are hypotheses, which are newly formed explanations that aren't proved yet. The rest are theories, which are half proved. They're not science facts, but they're half science facts. Still good enough to go around. Like the Omniverse is. I thought Omniverse has quite a lot of backup theories. This universe that we live in is one of the universes in a whole array of universes called dimensions. This theory is called the Multiverse theory. Our universe is like a puffed up balloon. All these purple lines are called the cosmic web. The cosmic web is what makes up the universe. Outside the cosmic web is complete darkness except a few clusters of galaxies, mostly dwarf. So you see this is the cosmic web. Outside these arrays is only dwarf galaxies. Here you have a galaxy cluster. Here are galaxy clusters. Over here is a hypermassive galaxy cluster. It looks like a huge puffed out galaxy, doesn't it? That's exactly what it is. Inside there, all those tiny bits are tiny galaxies contained. See here? You see down tiny there, that tiny little spot. This tiny little spot is how tiny the Milky Way is compared to the whole of this galaxy. This supercluster. Theory number 1: white holes. White holes are the opposites and remains of a black hole. White holes use a tunneling wormhole to transfer energy to it to pump out into this universe. What it might cause is that this universe, how it appeared, is still unknown. But after all that stuff, all the hypotheses or how it appeared, the white hole tunneling wormhole transfers energy from another point or another part of this dimension to bring all the way to here in an incredibly fast amount of time, because wormholes cut through the fabric of space and time like a shortcut. All the energy comes out from the wormholes, which appears to be flying outwards. What it's really doing is swirling outwards to bring all the matter in this universe to give this universe energy. If this white hole hadn't appeared in this theory or this universe had to go to the hard way of getting energy, fusing the fabric of space and time together, which would be the cause of the Big Bang if it was fusing together. So the white hole is an easy option of fusing tiny things to become larger and larger. So what you could say is a cheat. Okay, for example, I have this blue balloon with tiny dots in it. How the white hole spreads energy will expand the territory of this universe. Now watch what happened. If I can't blow this balloon up, that is. This is the balloon I recently blown up, but I haven't tied it, which is a problem. So, say goodbye to this. So, you see all these, they're just galaxies, uncoloured. I'll get a new balloon that is blown up and tied for you. So, say away. Okay, this is the balloon I previously made. You see here, these are all the figments of this universe. Galaxy cluster, which looks a bit like a crab. There's a proper galaxy cluster, have a pushed out galaxy, which we'll go closer. And then, so the universe could be this shape or could be not. The wormhole could be a tiny pot, could be this bit outside this bit of the universe. This is the wormhole that we made. This bit is the tunneling energy. For example, this universe, which might be a tiny universe, there's a wormhole that disappeared and it got energy transferred to my hand. This will inflate this universe to quite a massive size for the micro universe. So galaxy would be about size this if it was sealed by my hand, which is still quite impressive. And the white hole also gives this universe energy to move about to this omniverse. Say for example, the room around all this room, the space in all this room is the omniverse, and this is our universe floating about. Pretend my hand's not there, and this thing is floating by its own energy. So what it would be is a floating balloon-like universe in the whole vastness of space. And what you wouldn't want to do is get another balloon, for example this squiggly balloon that's just forming and exploded and collide together, which would be inside there a catastrophic explosion which would blow these two apart. As if I already did. The good thing is I haven't popped it, so this thing can keep on forming. What would happen to the growing universe is that these galaxies would be like this. All history. These galaxies here will be history. So, bye-bye galaxies. Okay, this here is a diagram of how the universe will and how it began. How it began and will it end. So this is the Big Bang. The most trusted theory of how the universe began. This is all the matter and particles. They're fizzing around like a big asteroid bombardment in a parade. Well, at least you know not going crazy fizzing around the base. So these tiny sparks are called quarks. They make the fundamental elements, the elementary particles that make almost everything we see. These quarks have a top-bottom strange, and all new quarks that are coming. These are new uniform particles. These particles that make everything we see, well, almost everything we see, are the fundamental particles or the elementary particles. These make everything we see. These here are newly formed galaxies, and these blobs are called lime and alpha blobs. They're the beginning of galaxies. We see here, that's how it is now. This is Hubble's ultra deep field, ultra field. See, all these galaxies are being formed from the early ages of the universe. You see, as you get farther on, you see less and less and less galaxies until you come to one point that you can't see a single galaxy. Not a single one, except points and points of fizzing particles. That's because our eyes are a time machine. If you look at something that's far away, you see it back in time. 1 AU, which is astronomical unit, contributes to 8 minutes in the past. Scientists know this because Earth is 1 AU from the Sun, astronomical unit. Which means, and they figured out that Sun, we're seeing the Sun back in time, 8 minutes. So if we're 1 astronomical unit away from the Sun, and we see it 8 minutes past, that means 1 AU contributes to 8 minutes. Back to the beginning of the universe. This is the universe now. This is what we are now. All the galaxies swirling perfectly. They're swirling. They could be the Milky Way spiral galaxies on the plot, the regular galaxies. But if this way, these galaxies are getting small. These galaxies are getting smaller. This universe is getting smaller because the force of gravity. And the other hand is getting bigger and bigger and bigger till it streaks on light. So you see the galaxies are coming together so close. And then here, that is a collapsing point where everything collapses into one single tiny black hole, which eventually dies out, and that becomes the end of the universe. Whereas here, the universe is still existing, but the galaxies are getting so stretched apart that they're only tiny blobs of light, and then they're so far apart that they're just a blob of light 1 centimeter across, like the normal stars. So amazing. This is the radiation background viewed in X-rays, microwaves. These show beginnings of the universe. Well, parts of the beginning of the universe. The more closer the colour is to red, the more denser and the more hotter and the more active parts they were. So these blue bits are active, resting, and parts that, well, are doing almost nothing. Well, these pink and red parts, which you can barely see, well, a bit like orange, these parts are high, fizzing, active, parading, colliding, collapsing, particles that are fizzing around the place. Like a bouncing trampoline room plate or a celebration. Since they're so active, that's where galaxies normally form. Whereas the blue bits, they're so inactive that galaxies rarely form there. Well, not exactly rarely, but compared to the other bits, rarely. Except colours related to black, however. But that means the highest density colour is white. So the more light, but then the more denser parts, more hotter. That's where the confusion comes. White is just after red. The more closer it is to white, red, then more closer it is to red, then more hotter. But then you can't contribute to white, which is so confusing even I can't comprehend it. So this is the ending of the universe, and this theory means that the universe is still going to be here, which is kind of it for me. Unless black holes take over and devour everything again, which would be, well, catastrophic. But I haven't heard about any black hole devouring a galaxy yet, so maybe that won't happen, or maybe it will. Who knows? Maybe the galaxy will devour the whole of the Omniverse, or maybe not. Theory number 1. The wormhole. This is a wormhole. It's a passage to the fabric of space and time. More simpler words, a shortcut. For example, if a wormhole appeared right now, say for example this. I put my hand in, but as soon as I put my hand in, it would break. Because you need a stabilizer. Something to strengthen these walls of the wormhole. If you don't, and you just pass through, your body will snap like the wormhole. In most cases, you use light matter, a huge amount of light matter. The problem is, where do you gather it? Well, you can't put yourself in, can you? That would kind of be like risking your life. So what scientists are trying to do is collide particles, is get a whole bunch of particles, which is almost always possible, but then the problem is trying to trap it. Because electrons and protons and particles have a new process. They have a new process which they can pass through, and they can borrow energy from different time periods. Which may sound absurd, but they can't. So that's the problem is. Back to the wormholes. Once you've done all the calculations, got enough light matter, you have to step through. But be aware, you can't stay there for long. Unless the stabilizer, you have thousands of tons of light matter, which has already put in. You have to put it in both sides. So once you get there, the first thing you do, put the stabilizer light matter in, or else you won't be able to return. Then enjoy vacation and step out. In terms of gamma rays and shock rays and hypernovas, supernovas, black holes can't stand it. If you are close without backup, so for example, if a star goes in alone inside a black hole can't handle it. Where there's two stars going inside a black hole, the black hole can't stand it. So either it will evaporate, or the energy will be consumed by the two binary stars. Well, if the stars aren't binary, they will become binary because of the black hole, because they're attracting them to opposite side, or maybe not. With their own gravity, they will start orbiting each other like planets orbiting a star. Okay, what I'm going to explain now is my opinion, my theory of how the universe began. First, it starts with the fabric of space and time. Well, that is not my theory. everybody, well, almost everybody knows that Einstein came up with that theory. But then that's when my theory comes into place. What I think is that it was just nothing. No, the fabric of space and time. What made the fabric of space and time? That goes into a completely new theory called the Omniverse theory, which, well, we don't know what caused it. But after all that, the fabric of space and time happened, there was a collision. Well, collisions happen a lot. This time, every single second, matter and dark matter are colliding. Every single day, every single second, every single year, there are millions of collisions. So why couldn't it happen back then? Well, there was fabric and space and time, so there were layers and layers of fabric and space and time. So something caused the collision. The source is unknown. Well, after a new era of hypotheses and theories, the fabric and space and time collided together, which caused a massive explosion. Because if the fabric of space and time collide, the consequences are catastrophic. So if two dimensions of one day of the fabric of space and time collide, catastrophic explosion happens. The explosion is so big that it's more than thousands of supernovae exploding at one time. That's not what scientists call the Big Bang. This new theory might explain that the shock wave creating more disturbances in the fabric of space and time, and more, which creates so much energy that the universe can't handle it, but to explode. So this created an outer layer. Like a star, it has to spread bit by bit. So then the universe became more like a star. It had layers. Since the universe has started to take shape, it needs a layer. It can't be just straight passed through, like water is, liquid is. Although it is kind of liquid but molten. So it formed a layer like other stars do, shaped into a spherical shape, but not exactly a sphere, but somewhere near the shape. As that happened, the universe was still expanding since it whole array of new energy from the explosion. So it exploded from the tiniest of a marble to the side of the sun in less than 5 seconds. But still, it is a big foreign universe, but going like that in 5 seconds is completely astonishing. So a minute, well, that would be 12 times the size of the sun, which would be massive. And then again and again. That's my theory how the universe began. So now that I've said my theory, I need to explain it. So what would a theory be without any explanation? No theory. A dead theory. So first, what is the fabric of space and time? The fabric of space and time is a theory developed by Einstein. He made this theory when he disproved Newton's theory of how gravity travels instantaneously. So if something disappears, for example, if the sun disappears and the earth is still orbiting it, then the earth's orbit will instantaneously disappear and it will go drifting off. That's when Einstein disproved it. But coming up with the theory of the fabric of space and time. But before he made that theory, he he still disproved Newton because he studied light a lot. He worked with light. Well, everybody worked with light because first thing first, you see the sun and the light is bouncing off you every single time. Second, camera ring, which is happening to me right now. What I'm having to do is staring right into the camera light, which can damage my eyes. Third, you use light to light up your rooms, so you're still interacting with it. Everybody interacts with light. They work with it, but what they don't do is study with it. That's what Einstein did. He studied light a lot. Which that theory, he came up with the fabric of space and time in his theory of relativity, which then he split up into two parts: general relativity and special relativity, which are now the two top theories almost scientists use, as well as quantum mechanics, which explain everything but gravity. Like a trampoline, something with huge mass will cause like a huge hole, but not bottomless, but a hole in the fabric of space and time because of the mass. So, something as big as the Earth and the Moon will cause that. And if the Earth caused that, there's no reason why the Sun wouldn't, since it's extreme mass and it's way heavier than Earth, which is certain, since it's a big star. It has so much fuel. It's been burning for a few billion years. So Einstein came up with the theory that the mass caused a huge hole in the fabric of space and time. So even if you go to Enceladus, you see the sun is just a point like that. But even that is the furthest region of the solar system. So if something as massive as the sun could do that, think of something like Beetlejuice would make a hole so massive. I mean, what was the Big Bang then? What caused the Big Bang is what my theory explains. But wait, first, what is the Big Bang? The Big Bang is the most accepted theory of how this universe began. Well, what scientists don't know is what caused the Big Bang. Well, the Big Bang is a theory, so scientists don't know if that what really happened. So the Big Bang, what scientists say, is a huge explosion. The explosion is so big that it was so powerful that even millions of supernovas couldn't match its power. It was 27 followed by 32 zeros. The temperature is 27 followed by 32 zeros degrees Fahrenheit. 27 followed by the 32 zeros, which would be 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0.0000000000000. A tremendous amount of zeros. So many that even scientists are too lazy that they can't even write it. They make a computer. They make a computer just write it instantaneously, since it's such a long number, uncomprehendable, off the human skills. So that's what the Big Bang is. Now my theory is that the collapsing of fabric in space and time are such a powerful event that even scientists doubt that they'll find a way to prevent something like that happening. Since it's so powerful, first it needs to find a way to protect the solar system as well. it'd be awkward having just one planet orbiting one sun. Well, unless the planet's like massive and like a bad repair. It'd be awkward for a star to be orbiting with a planet. Would be a planetary mind repair. Maybe not. My theory is a collapsion of fabric in space and time as such a powerful event that even scientists fear that they'll doubt, even in the future, find a way to stop such a massive, powerful event, such a powerful explosion. Well, if it ever happens. If it doesn't happen, we're lucky, but it's bound to happen sometime.